Page 4. If the mean vertical jump of a college freshman is 18 inches with a standard deviation of 3, what is the probability that the next random person will have a vertical jump height of at least 24? So, mean of the population is 18. And standard deviation of 3, so that'd be 21, 15, 12, 24, at least 24. So this is 50%, and we know what these two are. That's the 0.3413 plus this one, this area is 0.1359, which we've added several times, 0.4772, and we don't want those two. We want the upper piece here over 24, at least 24, 24 and more. So that's this area, so I'd have to take 0.5 minus this, which is 0.0228. Between 113, what? Between 13 and 18 inches. 13 and 18. So I'm going to have to figure out the z-score for 13. That was a typo. 113 and 18 would have been 50%. But between 13 and 18 is what I wanted you to do, or 11, but I'll do 13. So 13 and 18, so I'd have to get the z-score of that. So that would be 18 minus, no, 13 minus 18 over the standard deviation, which was 3. 13 minus 18 is minus 5 divided by 3, which is minus 1.67. So if I look up that z-score, 1.67 is 0.4525. 0.4525 is the probability that between that 13 and the center, and so to get, and that's all I need, so that's what I want, so 0.04525. Okay, now if I wanted to do that on a calculator on second distribution, normal cumulative between 13 and 18, comma, with a mean of 18, comma, and a standard deviation of 3, and that comes out to be 0.4522. Did I look at the wrong spot on the table here? Oh, we rounded that off 167, so that's why. Okay. What jump height would 60% of the freshmen exceed? 60%. So that would be going to be more than 50%. That would be 10% lower than the middle. So I'd want to find 10% on the table, which is about a z-score about 0.25 or 26255. I'll just do approximation. That would create a z-score of 0.255, and so if I set that equal to the raw score minus the mean over the standard deviation, I'll have to multiply by the standard deviation, so that's 0.255 times the standard deviation of 3 inches, then add the mean, which is 18, and I get times 3 plus 18. Oh, this is a negative z-score, excuse me, because we're on this side, not on that side. So I got to go back here and put it in a negative. I just realized that. And I get a score of 17.24, or a raw score of 17.24. So 60% of the students would be able to, if 50 can jump 18, 60 could jump 17.24, 17.25 inches. Now, if I want to do that on the calculator, I would have to say I want to add up the area up to that there. So the area would be 40% down there. That's how inverse norm works. So I go second inverse norm, and I want to have 0.4 with a population mean of 18 and a standard deviation of 3, and it tells me 17.239, which is rounds to 17.24. And what's the probability that at least one of the next 5, so now we're talking about binomial, will exceed the height in problem 10? Well, it should be part C. Part C right above, so that's an error in the test here. Exceed that. What's the probability? So there, each freshman has a probability of exceeding that height. It's 60% probability. And we're going to do 5 trials, because we're doing next 5 freshmen, and they will exceed that height 60% of the time. And so we're going to do, we need to know at least 1, so we don't want the none. It'd be 1 or 2 or 3 or 4 or 5. So I can do the binomial distribution. Let's see if I have that table. I'm not seeing it. Okay. Well, I can look up binomial 0. It would be with 5 trials, but I can do it on the calculator, so let's just do that. Binomial, I just want 0 only, with a 5 trials, probability of success 0.6, comma, and I want to know the 0, and that is a PDF, so I'm just figuring out 0, 5, comma, probability success 0.6, comma, no successes, and that turns out to be 0.0102, so 0.01, and then so that would be getting 0, and everything else would be at least 1, so I'd have to do 1 minus 0.0102, which is 0.9898. That's the probability that at least one of the next 5 freshmen will exceed the height of 17.24 inches. Okay, and now problem 10. The table of counts. What's the probability of B given A, B given A? So we can do, let's do the formula. The probability of B intersect A over, it's kind of like the division line, probability of A. The intersection is 10 out of, how many are there total here? 49, 53, 63, 73, 73, and 35. 7,308 total. I believe, I should probably check that. Plus 14 plus 35 plus 49. 108. And so the intersection probability is 10 out of 108 divided by the probability of A alone, which would be 45 out of 108. Notice the hundreds and eights cancel. I really didn't need to do that. I just needed to do 10 out of everything in A, which is 45. So that's, and 5 goes into both of those. That's 2/9, or 0.222 repeated. Now, if I want to check for independence, and I have that already, I want to compare it to the probability of B, or I could do the probability A given B and the probability of A, or other things, but let's find the probability of B. So that'd be 24 out of 108, which is, let's see what goes into both of those. 4. Yeah, 4 goes into that. That would be 6. 4 goes into that. 27. 3 goes into both of those. That would be 2/9. Same value. So, since the probability of B didn't change, these are independent. Okay? And that's our sample test.